welcome. I've started the recording, and this is our week 3 live lecture and hangout and discussion. And we may have other students that drop in at some point, but if they don't, then we'll just plod on. And so let's see, it's Jon Bek here, and Leonard is with me, and I think you're not on screen. That's fine. I personally have a face that was made for radio, so if I weren't the instructor, I would offer the same courtesy. So, all right. So I'm just going to slide our video out of the way, and I never know on Zoom whether it actually slides out of the way on the remote system or not. And I apologize if it's still on the, because I'm not seeing it on my screen now. So if it's in the way of the recording, I apologize, and I'll try and see what I can do about that. All right. So we were just looking at an insert from the week 2 doodle. If you want to take a look at that. And otherwise, I'm going to move on, and so back in the recording if you want to see that again. And we're going to do some parallel exercises from the week 3 work. So in our week 3 assignment, let's see, we have the original, the textbook asks this. I modified that to ask this. So it's saying, using the HIT database, show how many persons in the database reside in California. And so how many is a key that, or a clue that we're going to be looking at the count function. And so both of these are count functions. How many, and this is where the balance is greater than their credit limit. This one is where the state equals California. So structurally, these are very similar queries, which is why I build them that way. I build you something that's parallel to the textbook, and then I'll show you the textbook solution, and you should be able to build out your solution for the HIT database using the same techniques. Okay, so looking at TAL 14 for the week 3 chapter, says how many customers. So we're looking at the customer table, and so I always like to start, my approach, my gestalt for this is to select star. Let's first of all make sure we're in the TAL table. Actually, that's not TAL, that's the 117 database. Okay, so forgive me. So I've used that. Well, I wondered. No, TAL doesn't have. I've forgotten now. Let's say that's TAL. I think TAL has the credit limits, and 117 DB does not. Let's do it this way anyway. My approach is always to start with select star, and then whittle things down or modify as we need. Okay, so and this is going to be from the customer table. Okay, so let's go ahead and run that. And yeah, okay, TAL's the right one. So we got credit limit, and that makes sense because it's supposed to parallel the textbook, and TAL is the textbook exercise, TAL, Samaras, and Colonial. Okay, so now what we need to do is we need to say only those where the balance is more than the credit limit. Okay, so let's come up and work on that piece. We haven't got to the count. We're going to get there. So let's add the where clause, the filter next. So where balance greater than credit limit. Okay, and let's run that. And there's 1. Okay, so now if we count that, we should come up with the number 1. So what do we want to do? We want to, instead of select star, we want the count of, and then the question then becomes, what do we put in there? We could say star, which is all rows. Sometimes you might have rows. If you're counting on a field that allows nulls, then you might have some null fields in there, and that would, so let's say we're counting on middle names, count of middle names having some criteria. Some middle names may be null, and if you didn't want to count those that are empty, then you would want to use something other than star. So here, so we could do this on star. We could do this on oh goodness, use the key field, customer num amounts to the same thing. Generally speaking, if the data is pretty clean, we don't have to give a lot of thought to that, but it is something to remember down the line. Okay, so we counted that, and we got a ground total of 1. Okay, so there we go. All right, so let's take a look at a parallel situation for the next one. Okay, so I think the next exercise says something like, and let's go ahead and break this so it is more readable. There we go. I'm just commenting that out. Okay, so the textbook question is, list the item number, description, and on-hand value of each item whose number of units on hand is more than the average number of units on hand for all items. Okay, and the hint here is use a subquery. Our actual exercise is, using the HCIT database, list the lab code ID, lab name, lab units, and lab charge of each lab code whose lab Medicare charge is more than the average Medicare charge for all lab codes. Hint, use a subquery. And what both of these are trying to tell us with the use of subquery is we need to compare to a number that we don't know. And it's also a number that could change over time. So we want to determine that number, in this case, the average number of units on hand for all items. We want to determine that number dynamically at the same time that we then compare and on that number. So that's the subquery. So we can either start from the outside in or the inside out on this, and that's really, some students want to do it one way, some students prefer to do it the other way. Neither way is wrong. Let's start, in this case, I'm going to start from the inside out. So I need to know what the, what is it, the average number of units on hand for all items. Okay, so let's start with select star from items. And I'll use good habit. I like to break it there because I think it's easier for your mind to parse, especially when you're first starting to learn SQL. So, and it's probably not items, it's probably item. Yeah. Okay. So, so there's our items, and we want the units on hand is more than the average. So we have to know the average number for all items. So what we need to do then is we need to get, instead of star, we're only interested in what? We're interested in on hand. So we're gonna prune this down. We're gonna chip away at it a little bit at a time. So there's the on hands, but what we want is not just the on hands. We want the average for all on hands. Once we know that number, okay, so there's that number without any formatting or whatnot. So 41.533333333. Okay, so what we want to do is we want to find the query of item number. So we're going to select, again, let's say select star from item. Okay, and then let's just run that because then we can really easily see our field names. And if we take a look at the field names now here are listed in the top, so we can get the exact field names. So it says list the item number, and that's item num. The description and the on-hand value. of each item that is more than the average number. Okay, I'm going to show you now. I'm going to run both these together. We'll see two results in our windows. Okay. So I see on the top the results of the first query. Let me scroll it down so you can see the query code. So here I have item number, description on hand from item, and here is the average. And so what we really want to say is we want to say where on hand is, and what did it say, greater or less than? It said more than, okay. So in a sense, what we would like to say is greater than 41.5333, right? And we could run it that way, and that would give us, for the moment, the correct answer. Our data is going to change over time, and so the average is going to change over time, and we don't want this to be hard-coded. So what we want to do is we want to find a way to combine these two queries dynamically, and we do that with a subquery. And so what we do is simply break this here and put this whole expression into parentheses. So the innermost query in parentheses is going to run first. The subquery always runs first. We can even have sub-subqueries or sub-sub-subqueries. It always runs from the inside toward the outside. So first it's going to resolve that and give us that number, and then it's going to compare the rest of this processing on the number determined here, and that does it all in one step. And so again, we didn't see a lot change there, but that's because you know, we had used the same absolute value, the same literal value, because we looked it up. But this does it so if it changes, if the average changes as we add more data or more transactions happen, and the stock goes up and down, the average moves, this query will continue to be correct even as the data moves. And so that's the utility of being able to do those two steps in one. Okay. Great. All right. Well, let's move along and take a look at another one if you're willing. And let's see. So that was the second problem. The third problem looks like this. So the exercise you've been assigned says, using the HCIT database, determine what is the patient ID, gender, and patient date of birth of the oldest person in the database. And again, the hint here is use a subquery. And if you're familiar with the top inquiry, I'm asking you not to use that method. I don't want you to solve this with a top inquiry. The other one that you may be familiar with from other databases is the limit query. Microsoft SQL Server uses a dialect of SQL that uses top N. Other databases like MySQL use limit. Okay, I think Oracle also uses limit. So there would be a way to do it with a top N or a limit query. I want you to do it in another way. So we're going to do that with a subquery. What we're actually going to do is answer the question, what is the item number, description, and price of the least expensive item in the database? Okay. Now, before we did it from the inside out, let's work with this one from the outside in. Okay. So we want, let's start with our old friend, select star from, and looks like items. Okay. So there's the whole shoot and match on items. And let's start trimming this down. We only want the item number, description, and price. Okay, so we've now cut it off horizontally. We're only giving the item number, description, and price, but of the least expensive item in the database. Okay, now one way we can get a look at this pretty easily and by default it's going to be ascending. We could say ascending explicitly. Well, there it is. That's the least expensive item in the database, but we also got the rest of this baggage. And now you can see where we could have used a top in. If we limited it to 1, we would only get the cheapest item. But that's not how they asked us to do it. So we can't use this. We just use this to kind of get a look. That's the one we're looking for. Okay. So how can we do this with a query? And we need a subquery. Well, let's see. So what kind of query could we use that would tell us, just give me the minimum price from item. Can it be that simple using the min function? It should be, if it's right, it should be 1095, right? 1095. Aha. So now we can get rid of this order by, and we could say where price equals the same value as the cheapest thing in the database, and there it is. Nifty.
Very interesting.
Okay. Does that make sense to you, the approach we took?
Yes.
The step that I left out this time that might have helped to connect us is before we put this in here, before we did it inside out, we solved this part first. So just run that part 1095. So I could say, well, 1095 is currently the cheapest. So if I run that, I will get the right answer. The problem is tomorrow, let's say that another item goes on sale, or we start stocking a new item that's cheaper, then 1095 is not going to be correct. How can I create a query that's going to be right no matter how the data in the database changes? And the way to do that is say, what expression will dynamically give me this value, not the literal value 1095, but the value of the least expensive thing. We could just as easily have asked for the most expensive thing. So we've looked at average and we've looked at min. If you had asked me for the most expensive thing, I could change that function to max, and it says, oh, the most expensive thing we sell is the rocking horse at $124.95 today. The data may change later. This query will always tell me what the most expensive item in the database is. So,
okay, perfect.
So, and if you were curious and you wanted to see the way I told you not to do it, and won't give you any points for it if you do, but the other thing we had done is that we said select item from item, and we said order by price ascending, right? Okay, that gave us everything, but it gave us the cheapest thing first. Top one says cut it off after the first one. If by the same same token, if you wanted to know what the 5 cheapest things were in the database, this is what they are. So top in is not really in this unit. We're not studying that, but I always get asked that question, and students say, well, what's this other thing you're telling us not to do it? The reason why I didn't want to show you top in as yet, I don't mind showing it to you, but the emphasis was I want you to understand how to use subqueries, subselects, nested queries. And so if I allow you to use top in, then some clever people who are a little bit phobic about not wanting to use subqueries, because subqueries are sort of like the calculus of SQL, and they don't want to learn calculus. They're like, oh, I could do it this other way. Yeah, you could. One of the things that will blow the charge off of the complexity of subqueries, though, is to say, just work with the smallest innermost query. And once you get that, move out one step at a time, one step at a time, one step at a time, like you're kind of the reverse of peeling an onion. You're working from the inside of the onion out, and then it's not so complex. You just build it a piece at a time. That's kind of a bottom-up decomposition. Again, for some people, their mind works more top-down. That's fine. So build it from the outside in and keep whittling it down, whittling it down, whittling it down until you have all the pieces in. And once you've done that, you will have, again, the point of a query, a really good query, is the query works without having to have special knowledge of the characteristic of the data. So something like this would always give me the 5 cheapest products, no matter how the data changes from day to day or month to month. That query is going to be useful forever. So,
Okay.
all right, let's bring up a new one. Okay. So we've done average, we've done min, we've done max as a demo. Let's take a look now, getting into a little bit of database math. Let's do a sum. So, okay, so here's question number 4 in your homework, and it parallels question number 19 in the textbook chapter. Oh my goodness, only mine is much wordier. Okay. No, theirs is wordier. Mine is actually succinct, isn't it? No, mine's number 4. Mine's wordier. I lose again. Okay. So the textbook is saying list the sum of the balances of all customers for each sales rep. Okay. So we don't want the sum of the balances for all the customers. We may start with that initially, but that gives us a total for everybody for all sales reps. What I would like to know is for each individual sales rep, give me the sum of the balances. So who is the rep? Another way of looking at this is I'm asking, who's the rep that's doing the best job collecting on their customer accounts? Who's the rep that's letting his customer accounts go unpaid, or who have the biggest risk, biggest outstanding balance? Okay. It says order and group the results by the sales rep number, and that's really kind of a hint. You could, if you learn to read these things, you would realize, of course, I have to order and group it by the sales rep, because how did you want the information on a rep by rep basis? Well, that's grouped by, and ordering it by sales rep is just going to be nice, because then we'll have it in the sales rep. If we order it by the sales rep number or the sales rep name, then we would have that in an easy to look up report, because it's in some kind of order rather than just all jumbled. Okay, so your parallel exercise that you're going to do is on the HCIT database. You're going to get in the labs table, and you're going to list the count rather than the sum of the lab tests performed for each admission. How many, not how much, but how many lab tests were performed for each admission. Order and group by the results by admission ID. You can see why that would be of interest to an administrator, because if we know how many lab tests we're doing on an average admission, we can impute all kinds of interesting things. If we know what our average lab test is, we can figure out the costs. We can take a look and see, how do we compare to other institutions as far as are we over testing or under testing our population? What is the national average? What is the institutional best practice and whatnot? Are we routinely, our physicians routinely ordering tests that aren't really well considered? Can we tune that down a little bit, save costs, and also improve the speed of patient care, because we're not waiting on a bunch of unnecessary labs? So, lower the patient costs by not charging them for labs they don't need to run and getting them in and out the door, when they can be discharged, rather than waiting on lab tests that weren't necessary, that haven't come back yet, those kind of things. Okay, the hint here is, since lab code IDs are numeric, it is possible to calculate their sum. Well, but why would we do that? That doesn't really make very much sense. It's not a useful number. So in this case, we're going to do count instead of sum. So my exercise, again, I'm going to show you sum, But where I'm using this function sum, you could just about plug in the word count, the function count, and it'll work the same way. So let's take a look at number 19. List the sum of the balances of all customers. So select star from customer, from customer. I forget. Let's try it and see if it throws an error. Yeah. Oh, you know what? The reason I'm not getting IntelliSense, I forgot to give it the context. So if I could either say use tal, or
I think you have to rem the above lines as well.
oh yeah, I had to do that. But since I opened a new query window, I lost the context when I lost the query window. So I have a choice. I could either say use tal, and as soon as I say use tal, right? If I give it that that context and run it, now what's going to happen is my IntelliSense is going to come back. There it is, customer. Okay. The other thing that I could do is, because sometimes you might be working with multiple databases at once, assuming you have privilege over multiple databases, we could qualify it this way. Say use tal dot, and as soon as I say tal dot, then IntelliSense knows what I'm should know. I don't know why it's not saying it. Customer, and oh, didn't get this commented out. There we go. From tal dot customer. What? Oh, my guess is that if I go and look at how I created this database, I am probably dbo.ta. Okay, so now it's fully qualified. I'm the database owner, dbo.tal.customer or tal.dbo.customer. Let's see, is it that way? No, it's the other way. So it's tal.dbo.customer. Yeah, now I'm getting IntelliSense. So there's a fully qualified version. I think it's just as easy just to say use tal, run it one time, and then I don't have to put all the fully qualified stuff in there. Okay, so there's customer. Okay, using the list the sum of the balances of all customers for each sales rep. Order and group the results by. So it's going to be by sales rep, but let's see, the sum of the balances of all the customers. What would that look like? Let's just get the sum of all the customers. Okay, so I want the balances. There's all the balances of the customers. Here is the sum of the balance of all customers. So this is a ground total. Okay, but now I need to get it by each individual rep. Okay, so we want the rep number. And I've got that wrong somehow. Rep num. Yeah, there we go. Oop. Now what happens when I do it this way? It's not part of the aggregate function. So as soon as I'm looking more than just a simple sum, I need to put it into a grouping because otherwise I can't do the aggregation. Sum is an aggregate function. Okay. Group by rep num. And now I have 3 reps, 15, 30, and 45, and there's the sum of the customer balances. Did I actually answer the question being posed? List the sum of the balances of all customers for each sales rep, order and group by the results by sales rep number. Okay, it says order and group by. I did the grouping, And it so happens that 15, 30, 45 is how the rep numbers fell out. That won't necessarily be the case, okay? That's more of a side effect of the way that the data on this real small data set happened to be entered. They were entered in order. You can't count on that. And on time, in time, we're gonna add new reps, we're gonna delete reps, we might have a region that we have to change a rep number. I don't know what it would be, but we might. And so what we wanna do is make sure that we put the order in. And so even though that's not going to change the output, this is logically ordered, whereas before, when we only had this part, it was not logically ordered, and that'll cost you half a point, my friends. So don't forget that if it says order and group by. And so let's gain let's practice parsing the question to make sure we've gotten all the points. List the sum of the balances. Do we have the sum of the balances? We do. Of all customers. Does this pertain to all customers? Yeah, there's not a where clause that's filtering it, so that's all customers. For each sales rep, is that all the sales reps? Yeah, and we could test that. Select distinct rep num from customer, all right? And just run that part. 15, 30, and 45. So that's all of the different reps that have any records in there. Now, is it possible that there are reps who don't have any numbers? Yeah, in another table, it is possible in the rep table, we might have just hired a new rep who hasn't started selling anything yet. So, but we really don't care about them for these purposes. So good point. Those who are SQL lawyers and wanted to trip me up, I can see the point. But within the customer table, obviously, a rep who is brand new and doesn't have any customers yet, of course, their customer balance is going to be zero. It's not really meaningful. So I would say, asked and answered, and the court is moving on. Okay. So I think we've about beaten that one to death. We checked some balances, all customers, each sales rep, order and group by the sales rep number, and there we go. We've got the aggregate function. Okay, so we can replace this sum with just about anything that is an aggregate function, whether we made that count, min, max, average. There's a few other more esoteric aggregate functions, but those are the typical ones. Okay, so that's how to build the group by, and group by clauses are maddening to learn at first. And what we usually have a problem with is we'll have a field in there that is not part of the clause. So if we come over here and let's grab another field. What's another field on that table, on the customer table? If I go take a look at the columns in there, let's sneak a peek. Okay, so let's just grab city. Okay, and if I take city here, if it's not part of the group by clause, and go to run it, you think, well, that looks just fine. And then things go to pieces, and you're like, oh, what am I doing wrong? I just can't understand it. Usually when you get a problem like this, it's not contained in the aggregate function. You're trying to do too much at once. The group by, you really want to keep the group by to the bare minimum that you need to answer the question at hand. If we really need to include that with another bunch of results, we can do it by joining these results to another table, even to itself, in order to elaborate it. But the group by really has to include all of, or subsume all of the attributes, all the fields that are in the query. And so it's usually the thing being grouped by, and then the aggregate values. You keep it simple.
So it's specific to what you're selecting.
Right, right. Because otherwise you start to, syntactically go like, well, does that mean all of them or not all of them? Or it confuses the issue. And if it can't be resolved in a unique way. Ambiguity is absolutely not allowed in any kind of computer programming, and SQL is no exception. So if we have another field in there that is not part of the group by clause, then we get that error, and it says, I don't know what to do with this because you got a field hanging out that isn't really part of it. Did you want me to do something to aggregate the thing you were referencing that wasn't included, or is that supposed to be part of the group by? Yeah, SQL can't just guess. So really best to keep these things simple. Then what we could do is if we needed to take this and include it as a sub-select or a union or part of a join, we could join it back and get the other fields. But answer the core question first is my recommendation on the group by queries. All right, so that's number 4. Let's take a look at a parallel for number 5. All right, and let's break this up a little bit. Okay, so your actual homework exercise says, using the HCIT database, use the labs table to list the count, again, an aggregate function, of the lab tests performed for each. Boy, that phrase, for each, is kind of telling. When we see for each, it almost screams that we're going to do a group by here. So we're going to group by admission. Order and group the results by, admission ID. Yeah, there it is. So even if I hadn't spelled that out for you, it should have been implied. So big hint in all capital letters here. Limit the output to only those admissions having fewer. So anytime I say limit the output, right away, that's a filter. And when I say filter, you ought to think where clause. To only those admissions having fewer than 100 lab tests performed during the admission. Okay, so here we're doing another count and group by, another aggregation query, but before we hadn't thrown in a where clause. Now we're throwing in a where clause. That's all. So this should be a parallel exercise. Let's read it and see if it's true. Is this also a group by query doing aggregation and then adding a where clause? List the sum of the balances of all customers for each sales rep. Well, we did that. But, here it is. Restrict the output. Restrict the output is as good as saying limit the output to only. That's a where clause. That's a filter. Those sales reps for which the sum is more than $5,000, order the results by sales rep number. Okay, so let's get your exercise out of the way. I won't have that much to comment out. Remember to comment it out this time. And list the sum of the balance of all customers. So I'm doing stuff on customers again. Let's start simple. Select star from customer. Bam. Okay. List the sum of the balances. Okay. So I'm interested in balances for all customer, for each sales rep. Okay. So I need to have the rep. I think it was rep num. Does that work? Yeah. Rep num, but restrict the output to those sales reps for which the sum is more than $5,000. Okay, we'll get to that. Right now, I've got the rep num and the balance. Okay, list this, but I need the sum of the balance. And if I try and do that, it's going to complain at me, right? It's going to say, you're doing an aggregate, but you don't, you've got another. If you were just doing the aggregate, we could give it to you. But you're now trying to throw something in rep num. Did you mean to do a group by? Why, yes, I did. And this ought to look familiar because we just essentially did this. Okay, so now I have the sum of the balances of all customers by each sales rep. Okay, restrict the output to those sales reps for which the sum is more than $5,000. Where can I use sum again? Because I have to say the sum of the balances is greater than 5,000. Can I do that? Let's find out. And let's put the group by in the right location, following the where clause. That may be on a test in your near future. So take note of that. Does the group by clause go before or after the where clause? What happened?
That was good to know right there.
It's always good to come to the Hangouts, I'm telling you. Okay. An aggregate may not appear in the where clause unless it is in the subquery containing a having clause. Ah, okay. So let's see, what is it telling us here? An aggregate may not appear in the where clause unless it is in a subquery, okay, contained in that. So what are we gonna do to get it there? So let's see here. There is an alternative to the where clause. It is called the having clause, and the group precedes the having. Does that solve the problem? So select rep num sum balance from customer, group by rep num, having sum balance less than 5,000. Always good to sanity check these things. How could we sanity check these things? How about we say select star from customer where sum balance greater than 5,000. Is that right or is that wrong? Think about it. Not aggregated, right? Does this work? Nope, not aggregated. Can we just do it? This way. Well, the problem with that is it's disaggregated. It's just the sum of everything. Okay, so really the easiest way to do this is going to be select num sum of the balance from customer, group by rep num, having sum balance of 5,000. Now we could aggregate this and look at the individual balances and say, does this then give us the correct 15 and 45? So if we wanted to test, if we wanted to sanity test this, we would need to come and break it down and say, okay, what I really want to do is I really want to select rep num sum of the balance from customer, group by rep num. And let's see all of them without the filtering. Okay, and so if we now eyeball it, this is more than 5,000, he should be included, rep 15. This is more than 5,000, she should be included, rep 45. Rep 30 should be cut out, and if we add this in and do it that way, well, that's just exactly what we expected. So you can still sanity check it, it just takes a little bit more drill down on the numbers, and it's worth the time, especially when you're learning to sanity check it, because the thing to remember is just because the syntax works doesn't mean the logic is correct. And so taking the extra time to play with it, I think will help cement your understanding. But when all is said and done, if you built it this way, that's a full credit answer right there. Okay, let's do another one. We're about at time, but let's do one more if you're willing.
All right.
And so you said you hadn't looked these over before, right?
No, I haven't looked them over yet.
I'm going to skip ahead a little bit and see if we can get into one that's a little hairier, because it's always they always seem to get a little bit more complex toward the end, right?
All right.
So
Correct.
let's go look at one that's toward the end, maybe not the very last one, but let's build one that's a little bit more complicated because it's good to have those examples. So this is exercise 14. And it happens to also be exercise 14 in the textbook example as well. And let's break this down. Okay. So put succinctly, what the textbook is asking us to do in their sample, what is the average distance and the average maximum group size for each type of trip? Now we're over in the Colonial database. Let's take a look at that. Use Colonial. Good. Now we'll update our context. Now we're working in the Colonial schema. Okay. So in your actual homework, what it's saying, so what we're doing, well, let's start with what we're doing here in the textbook. We're doing an average distance and an average maximum group size. So maximum group size is a field and the distance is a field. So we're going to get two averages for each trip. And what did I say about that for each phrase? Anytime you see that, you almost always know that we're doing an aggregation. We're going to do a group by, okay, for each type of trip. And in Colonial, the different types of trip are paddling, biking, and hiking, I believe. Okay. So what we should see, if I've written a good parallel in the HCIT for you guys, is we should be doing a couple different types of aggregation on one of the HCIT databases at the same time. So it's going to be, there should be like a for each. So just for the sake of curiosity, let's explore what the average lab charge is and the average lab Medicare charge. So we're taking two averages at once. When we group the labs, so I've explicitly told you we're going to group the labs based on lab units of measure. Okay, so for lab tests, for some reason we want to, they're the same kind of units of measure, whatever that would be, picoliters or I don't know, inches of mercury or whatever you measure lab things in, picoliters or micrograms or whatever we're measuring. And it says, what is the average lab charge and average lab Medicare charge for lab codes by each lab units item? Display each lab units and order the outputs by lab units and label the calculated fields appropriately. Okay, so anytime I say label, we're going to use an alias. And the alias, the keyword to alias something is as. So if I'm looking at one thing and it's a calculated field and I say calculate that as total price, then the word total price would appear in place of the calculation, in the heading. Okay, so we'll see how to do that. So what is the average distance? Let's see here. Select star from trip. And again, let's break that up so it's easier to read. So there's our trip table. Has a trip ID, trip name, start location, state, the distance, the maximum group size, the type, and season. So this is like a guide service, and you want to rent out for your group to go with a guide. How many people can we take maximum, and what is the distance, and how are we going? Hiking, biking, or paddling? Okay, so let's start working this, breaking this down. What is the average distance and the average maximum group size, max group size, for each type of trip? Type. Okay, so these are what we're interested in: distance, max group size, and type. Let's put the type, because we're going to group it by type. Let's put the type right up here in the front. Get rid of that trailing comma. And then we want, just to make sure that still works, so now it's got type, distance, I've got them in the proper order. And now I want the average of the distance, and I want the average of the max group size. Group by type. And let's see, did it imply an order by? It didn't. I'm going to add it in just for an example, but I think that's not a half a point in jeopardy. What is the average distance of the average maximum group size? Yeah, it doesn't say it, so we could leave it off. I'm going to add this in, but it's optional. Order by type. Type. So, on average, biking type trips have no column name, because I didn't tell it. I need to give it a column name. They have an average distance of 17.125 miles, an average group size of 11.75. Here's how I put that alias in there. As and average distance, and as average max group size. Rerun it, and now we'll get nice labels there. So that replaced that average with the moniker. Also, I think actually SQL Server and most SQL syntax I've seen, you can drop that out. I think it makes it a little less clear that you're aliasing something when you're reading that. It might look like it's another field. So I like to leave it in. See, it worked anyway, but I like to explicitly call that out. Either way is a full credit answer. But there we go. So that one's a little bit hairier than the ones we did earlier. So we've seen one of the later more complicated. But really, if you work up to them, by the time you get to this, they kind of build on each other. If you've done them all successfully in order, the later ones shouldn't. By the time you've built a little muscle mass, it shouldn't be like it's beyond your strength by the end of the exercises.
Well, this was good. Thank you for allowing me to see how you drill in and drill out of these. Peeling the onions is I guess one of the challenges. We have to dissect how to break the question down.
Word problems are, just like in math in elementary school, word problems are always the toughest thing to decompose. You can find some key phrases that will help give you clues about it. It's one of those things that gets stronger with practice. Also, I'm showing you my way of doing it. It's not the only way. It's certainly not the only right way, and I don't even represent that it's the best way. It's a way that has worked well for me, and it's a way that has worked well for me in teaching this. So if it's useful, great. If you have another way that makes more sense to you, then number one, go with what allows you to find your success. And number two, please share it with us in the C1, B1, T1 weekly videos. If you've got a nifty way to approach or decompose the problem, we can all learn from that. And one of the reasons that this is one of my favorite classes to teach is I always learn so much from my students every time I do.
Okay, well, that's great.
All right.
Appreciate you coming out.
All right. I'm going to go ahead and stop the recording and wish you a good evening.
All right. Thank you, Dr. Beck.
Oh, I wish it was doctor, but I'm just Mr.
You get used to saying it.
You're very kind. Have a great evening.
You too. Bye-bye.
Bye.